Most PySpark interviews don't fail because you can't write the code. They fail because you don't understand what Spark is doing behind the scenes. And honestly, if you are a beginner, that's normal. Spark feels like magic until it doesn't. Hello everyone, welcome to Big Data Factory. I am Pranit and I have around 4 years of experience as a data engineer. So in this video, I will cover the most common PySpark theory questions in a way that's easy to understand, and I will also tell you why each concept matters in real jobs. I will keep it simple, practical, and interview friendly. And stay till the end because I will summarize everything into a 1 minute cheat sheet you can actually remember. Let's start with question 1. What is the difference between Spark and PySpark? So here, Spark is the engine, the actual system that runs distributed computations across many machines. PySpark is just the Python way to talk to Spark. So PySpark is like the remote control, Spark is the TV. Your Python code doesn't do the heavy lifting by itself, Spark does. That's why you can write Python code and still process huge data. So here is a small interview tip. If they ask, why is PySpark sometimes slower than Scala? The simple answer is that Python and Spark's core engine run in different worlds. So there is extra overhead when moving data between them. But for most real pipelines, PySpark is still a fantastic choice. And we move to question number 2. What is a driver and what are executors? This is one of the most important Spark basics. The driver is like the manager or the brain. It plans the job, builds the execution plan, and tells workers what to do. Executors are the workers. They actually run the tasks and process the data. A useful way to remember it, driver decides what to do, executors do the work. If your driver dies, your application usually dies. If an executor dies, Spark can often replace it and continue. This is why Spark is resilient. And we move to question number 3. What is the difference between an RDD and a data frame? Think of an RDD as the older, low-level way. It's just a distributed collection of records, like a list spread across machines. A data frame is higher level and structured. It has columns and schema like a table. The big advantage of data frames is optimization. With data frames, Spark can analyze your operations and optimize the plan before running it. With RDDs, Spark has less visibility, so it can't optimize as much. And here is a beginner rule. If you are doing data engineering work, filters, joins, aggregations, use data frames. Use RDDs only when you truly need low-level control. And question number 4, what are transformations and actions in Spark? This is the classic interview question. Transformations are operations that build up your logic, like filter, select, with column, join, group by. Actions or operations that actually trigger the job to run, like count, show, collect, write, take. Here is the key. Spark is lazy. That means transformations don't immediately execute. Spark waits until it sees an action. Then it runs everything in one optimized plan. This laziness is actually smart. It allows Spark to optimize and avoid unnecessary work. Quick example, if you filter a dataset and then do a count, Spark doesn't do filter now and count later as separate runs. It builds a plan and then executes efficiently when you call count. Question number 5. What is lazy evaluation and why does Spark use it? Lazy evaluation means Spark doesn't execute step by step immediately. It records what you want, builds a plan, then runs it only when needed. So why Spark does this? Because optimization and efficiency. It can reorder operations, combine steps, and reduce work. If you remember one line, Spark is like, tell me your full recipe first, then I will cook in the best way. In interviews, if someone asks, how do you know what Spark will execute? You can say, you can look at the plan using explain. That's how you see what Spark is thinking. And question number 6, what are narrow and wide transformations? This is where performance starts. A narrow transformation means each output partition depends on only one input partition. Examples like filter, select with column. So Spark can do this without moving data around the cluster. And a wide transformation means output partition depends on many input partitions. Examples group by, join, distinct order by. Wide transformations usually cause something called as shuffle. If you hear shuffle, translate it in your head as Spark is moving data across the network. That's expensive. So a really good beginner mindset is narrow transformations are usually cheap, wide transformations are usually expensive. And we move to the next question. What is a shuffle and why is it expensive? A shuffle is Spark redistributing data across executors so that similar keys end up together. For example, if you do a group by on customer ID, Spark needs to bring all rows of the same customer ID together. But those rows are spread across the cluster. So Spark moves data. Shuffle is expensive because it involves network transfer, disk input-output operations, and sorting or merging. That's why a job that looks simple like a group by can suddenly become slow. So here is a beginner performance tip. Reduce unnecessary shuffles. Avoid doing wide transformations too many times. And be careful with joins and group by on huge data. Question number 8. What is partition in Spark and why does it matter? Partitions are how Spark splits data for parallel processing. One very important line, one partition generally maps to one disk. More partitions can increase parallelism. But too many partitions can create overhead, like thousands of tiny tasks. So, too few partitions means your cluster sits idle. So, partitions are like the number of work chunks. In interviews, they might ask why adding more executors didn't speed up the job. A common answer is because you didn't have enough partitions or the data wasn't balanced across partitions. Spark can't magically create parallelism if there is not enough work chunks to distribute. Question number 9. What is cache versus persist and when should you use them? Both are ways to store intermediate results so Spark doesn't recompute them. Cache is basically a shortcut for persist with a default storage setting, usually memory only. Persist lets you choose the storage levels like memory plus disk. When should you use caching? When the same data frame is reused multiple times, like you filter a big dataset once and then you use it in multiple joins or aggregations. If you don't cache, Spark might recompute the same lineage again and again. But don't cache everything, memory is limited. And in real projects, always remember to unpersist if you cached something big and you are done with it. Question number 10, what is Data Skew and why do Spark jobs get stuck at 95%? This one is very real world. Data Skew happens when the data is not evenly distributed. Like one key has huge data and other keys have tiny data. Then one partition becomes massive and one task runs forever while the rest finish quickly. This is the job stuck at 95% situation. How do you detect it? In Spark UI, you will see one or two tasks taking way longer than others. How do you fix it? At a beginner level, remember, skew problems need skew solutions like changing the join strategy, using techniques like salting, or enabling adaptive query execution if your environment supports it. You don't need to memorize all fixes today. Just understand the diagnosis. One slow task often means skew. So if you're interested in Data Skew and you want to learn about Data Skew, so I already made a full video on what is Data Skew and how to resolve them. Click on the I button above and go watch that video. Now let's do the promised summary. So this is your 1-minute cheat sheet. Spark is the engine and PySpark is the Python interface to it. The driver is the brain and executors are the workers. Data frames are preferred over RDDs for most data engineering because they are optimized. Transformations build the plan, actions trigger execution. Spark is lazy, so it can optimize the plan. Narrow transformations are usually cheap because data stays in place. Wide transformations are expensive because they trigger shuffle. Shuffle is expensive because it moves data across network and disk. And partitions control parallelism. One partition typically equals one task. Cache and persist help when you reuse a data frame, but don't cache blindly. And data skew is when one key dominates and one task becomes the bottleneck. The classic 95% stuck job. So this is all for today. If you want part 2 of this video, come in PySpark and tell me what you want next, either joins, window functions, or Spark UI debugging. And if this video made these concepts clearer, subscribe because I am going to keep making interview-ready Spark and data engineering content that actually helps in real projects, not just definitions. We'll meet you in the next video. Till then, bye-bye.